So now we're looking at entropy. Entropy is disorder, and disorder is kind of a weird way to talk about things because it's like you're talking about negative order. Disorder is negative order. And most of the time when we talk about things, we aren't talking about like the negative version of something. But disorder, that's what we're looking for, is how disordered something is. Now in the textbook, there's a really interesting discussion about microstates and statistics on where you're going to find particles. And you can read up on that, but you're not going to be tested on that information. If you go into PChem, then you will learn more about that. Entropy is disorder, and you can really see it illustrated when you look at a solid versus a liquid versus a gas. So if you look over here at a solid, you can just actually see that is very ordered. Even if those little pieces were all vibrating really, really fast, it's very ordered. And they're all lined up and they're really good. You can see on this liquid, it's a bit more spread out. And if this were an actual video or something, these particles would be bumping into each other. Bump, 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 bump. They would be moving, but they wouldn't be moving all up in the flask. And they would kind of all, remember, liquids have that surface that they have to stay within. And they would be staying within that little area. But you can definitely say there'd be more movement. And just looking at it, it doesn't look as ordered. And finally, we have the gases. And the gases fill the whole container over here. And they're all really, really bouncing off of each other, bouncing off the container. There's a lot of disorder. Anytime you would take a snapshot of it, the next snapshot would look completely different, which would look different from the next one. And again, that's also disorder. Like every time you look at it, if it'll look different, that's more disorder to it. So for disorder, when something is really disordered or is more disordered, your S is positive. It's a positive number. And this is a term that messes people up for a while to think about it. So the more disorder you have, the more disorder right here, the more positive your S value becomes. So you can see right here, this S is greater than 0. I always like my signs to be the other way. But your S is greater than 0 as you're going in this direction, which means that this has more disorder. And this has the most disorder. And again, this is just looking at phase changes, not reactions. And then over here, you can see that this one is going in that same direction, that 0 is less than S. And so you can still see that it's going in the direction of more disorder and eventually ending up most disordered. And you do know we can force with pressure or temperature, we can force solids into liquid phases and into gaseous phases, but when we're doing that, we are making it more ordered. So when you make something more ordered, it's negative. More ordered, see, this is where it, like, sometimes people are like, what? Why is it negative? More ordered is negative. And that might seem weird, but that's how we've designated the terms there. More ordered is a negative value, and more disorder is positive. So the more and more disorder you have, the more positive you are. The more and more order that you have, the more negative you are. So delta S negative means you are more ordered. Our universe likes this. And the driving force here for enthalpy is to go in this direction to try to make more disorder. So there are some ways to predict disorder. First of all is that if you're looking at a reaction, that's in the context of a reaction. And I've got some examples that we're going to look at. So if you are making a more disordered phase, then, and you can tell that you're making something that's clearly more disordered, then you're going to be disordered. So like if you have solids and you are making a gas in the reaction, gases have an extremely high value. That is definitely an example of disorder, of making something disordered, or even a liquid to a gas. And as a little note, you'll also see AQ. So AQ is when something is dissolved in a liquid. So you would categorize those as the same, like aqueous in a liquid compared to a gas. That direction is going to be more disorder. So that's what you look at first. So if you can clearly see that on the left you have solids and on the right you have gases, you can immediately say you're going to have more disorder from that reaction. If all the phases are the same, so let's say that you have all solid, or all liquid, if all the phases are all the same, then what you want to look at is the number of particles you make, or molecules, or moles. So if you had 2 reactants, but you made 5 products, then that's also an idea behind being disordered. Lastly, if all the phases and the products are the same, like everything, it's all exactly the same, then what you would do is you'd base it on the mass. So if something is lighter, then it will be more disordered than if it's heavier. But that's the very last case scenario, very, very, very last case scenario. You most of the time are going to only be dealing with the first 2 cases, and really mostly the first case, and not worrying about that last case. So let's see if we can see what's going on here. So in this example, I've got a solid and a solid, so nothing's changing there, but I am also making a gas. So that trumps everyone. And so this is right here, this is becoming more disordered. So more disorder, which means that this delta S is going to be positive. Now if I look at this one here, I've got 1 gas on this side and 2 gases on the right side. So that's still an idea of you're making more of a certain kind of a phase. So this is also delta S is positive. Now if we look at this case, we'll see we've got a gas, a gas, a gas, and a gas. So they're all the same phases. So it's not like you're making, a phase or not a phase. But if you look at the particles or the number of moles of it, we've got 1 gas and 3 gases, and they're making 1 and 2 gases. So I basically have 4 things making 2 things. So in this case, I'm becoming more ordered, and so my delta S is negative.